Well, good morning, everyone, and happy Halloween to all of you. It's great to be with all of you. My name is Professor Whedon, and I'm going to do a demonstration this morning on high voltage electricity. Lots of fun. And you may wonder, what is electricity? Well, electricity is that power that lights up our buildings, our businesses, our schools, our homes, farms, and factories. It's a very important thing for our life, but as you can imagine, it's also a very dangerous thing, and that's what this demonstration is all about this morning. And thank you for joining us. We really appreciate it. Before I get started with the demonstration, I think it's important for us to talk about some of the laws, some of the principles about electricity. How does it work, and why does it go where it's supposed to go? So let's start with one very important fact about electricity. How does it get to us? What does it travel through? What does it flow through to get to us so we can use it? Well, the items that I'm talking about, they're called conductors. Now you're thinking, is that the person that steers the train down the track? Well, yeah, that is a conductor. You may be thinking, is that the person that leads the symphony orchestra? That too is a conductor. But when you're talking about electricity, these are things that electricity can use to move from one place to another. For instance, how does it get from a power plant to our communities? The power lines. Now, what are the power lines made out of? They are made out of metal. So metal is a conductor. So you're talking about steel and copper and aluminum and gold and titanium. Anything made out of metal can be a conductor for electricity. And you may wonder, why? Why does electricity want to travel through something made out of metal? Well, some of you know the answer to this. It's because electricity is a type of magnetism. In other words, when you generate electricity at a power plant, the generators, those big, huge machines, are giant magnets spinning around coils of copper wire to generate all of our electricity. So when it comes out of the generator, it's magnetized. Well, what do magnets stick to? Metal. So does electricity. So that's why it flows through metal. And that's how it gets to our communities. The other conductor, though, and this one doesn't make as much sense to a lot of people, is water. Electricity loves to flow through water. And you may be thinking, well, water doesn't like, or magnets don't like electricity, so why would electricity want to flow through something like that? Well, it has to do with little teeny tiny atoms, little tiny neutrons and protons and electrons, and when water and electricity touch each other, they match like pieces of a puzzle coming together. And so electricity says, whoa, look at this, I can travel through water because of our little tiny atoms. You don't have to worry about that so much. What I am wondering, though, is can you think about things that need water to live and grow? Because anything that has water in it, it's a conductor. So what are some of those things? I know you know the answer to this. Animals, plants, and here's the big one, people, human beings. Over 70% of our body is water, and so guess what that makes us? We are conductors. And so that's why people do get shocked by electricity. That's why we do these demonstrations, to remind everybody, be really careful with it. Okay, here's another fact about electricity. Even though conductors allow the flow of electricity, there are some things that will stop it or slow it down. We call those things insulators or insulation. So what are those? Well, there are three main categories of those. Rubber is a good one, and you're going to see me wearing some rubber gloves here in a few minutes that will help me so I don't get shocked by this machine. So rubber is an insulator, glass is an insulator, and plastic is an insulator. But does that mean everything made out of rubber, plastic, and glass can protect us from electricity? No. It's got to be specially made so that electricity cannot get through it. All right, here's another good one. Some of you know the answer to this one. How fast does electricity travel? Because it travels pretty fast, as you know. It can zip through power lines and through extension cords to help us turn things on. Well, believe it or not, electricity travels the speed of light. The fastest thing that we are aware of, light speed, electricity speed, they're pretty much the same thing. But how fast is that? Well, that's 186,000 miles per second. Not per hour, not even per minute, per second. So how fast is that? Well, if you and I could travel that fast, if we could travel in a rocket to the moon, it would only take us a little over a second to get to the moon. It would take us 8 minutes to reach the sun. Not that we want to travel to the sun, it's pretty warm up there, but we could be there in 8 minutes. That's how fast the speed of light is, and the speed of electricity. So you can imagine, that's why it's so dangerous. We can't run away from it. We can't get away from it. So whether it's Mother Nature's lightning or the human-made electricity, It travels at the speed of light. One last thing here. And many people have heard this and maybe you don't understand what we're talking about, but we always say electricity is always looking for the easiest path to the ground. It wants to go to the ground. You may be wondering, why? Why does electricity want to go to the ground? Well, here's why. Now think about this. Isn't the Earth a giant conductor? It is. Most of the Earth is water, and we said water is a conductor. So there's one reason it wants to go to the Earth, because the Earth is a conductor. And here's the big one. Isn't the Earth a giant magnet? Yes. Remember, the core of the Earth, as we're spinning through space, is creating gravity so we don't go flying off into space. So electricity is attracted to the magnetism of the Earth. So that's why it always wants to go to the Earth, finding that easiest path. And that really helps us explain what's happening in this scenario right here. This board that we're about to explain, it's always wanting to find a path to the ground. And sadly, sometimes that could be through us. All right, let me explain the board here. I have this wonderful electricity board plugged into an outlet, and our outlets and our extension cords for our homes and our schools give us about 120 volts of electricity. That's a way of measuring it. 120 volts, which is still pretty dangerous, very dangerous. We don't want to put things in outlets that don't belong there. We don't want to chew on the extension cords. But inside this house where I have it plugged in, there is a machine inside there called a transformer. I know some of you are thinking, is that a robot that's going to change into a truck or a jet? I wish it was, but these transformers, this is what helps us increase the voltage of the electricity or decrease the voltage. So this one inside here, and I can't show it to you, but the transformer inside here is going to increase the voltage from 120 volts to 15,000 volts. A pretty big increase. So when I put things on the table here and get them close to the power lines, it's actually going to shock them with 15,000 volts, and you're going to actually see it. That's the fun part. So let's get started with the first scenario right here. The person on the rooftop, and you may be wondering, why do people get on the rooftops? There are a lot of different reasons, as we know. Somebody could be blowing off the leaves off the rooftop. This time of year, it's in the early autumn, the leaves are starting to fall. Maybe they're cleaning the rain gutters. Maybe here in the next few weeks, they could be putting up Christmas lights. So a lot of different scenarios for getting on the rooftop. But we always need to be careful because a lot of neighborhoods still have overhead power lines running right over the rooftops. The gentleman I'm going to show you right now, he's putting up a radio antenna, which is another reason for getting on the rooftop. Sadly though, he forgets for just a split second that he's got high voltage power lines with 15,000 volts flowing through it. So now I need to protect myself, so I'm going to put on my rubber gloves and my safety goggles and use my insulated stick to show you this scenario. The man on the rooftop with a TV antenna that forgets for just a split second that he's got the high voltage power lines. And here's the result, unfortunately. Okay, so you may be wondering, did the man get electrocuted? You probably didn't see it, but he did. You saw what we call the arcing of electricity. That's when a conductor gets close enough to the power lines, it may not have to touch it at all. And so the electricity saw a path through the antenna, through the man, and into the house. So even though you didn't see him getting electrocuted, he did, unfortunately. All right, next scenario. It's not really the time of year for doing this, but we all love to fly kites or watch people flying kites, usually in the spring of the year. But there are some issues when it comes to flying kites near power lines. I think we all know we shouldn't. But why? So let's talk about the kite itself. People tell me all the time, well, kites are made out of plastic, so shouldn't that protect me? No, the kites are so flimsy that they're going to melt or burn from the electricity and the heat from the electricity. But here's the thing that a lot of people forget about. The electricity now is going down the string, and remember how fast it's traveling down the string? The speed of light, 186,000 miles per second going down that string toward you. And my point is this, people tell me all the time, well, if my kite hits a power line, I'll just let go of the string. Oh my goodness. Are you going to be able to let go of your string fast enough? No, it has already gone down the string at 186,000 miles per second, so you can't get away from it. So what should you do? Fly your kite in a wide open area, a park, a playground, a field out in the country, and away from the power lines. So let me show you this scenario here again. I'm going to put on my gloves and my glasses to protect myself, but watch the arcing up here near the kite. And so as you witnessed, the man did get electrocuted by flying his kite into the power line. You saw the arcing, but as you can imagine, the kite or the electricity went down the string at the speed of light. All right, let's use another scenario that a lot of people might think about, but maybe don't completely understand, and that's power lines on the ground. What causes a power line to fall down? I think we've seen a lot of this over the last year or so. A lot of hurricanes, a lot of fires, a lot of natural disasters, a lot of wind and weather-related causes that make our power lines fall down. Well, does that mean they've been turned off? Did we just run out and turn them off? No, a lot of times they're still on until our crews can go out and turn things off and safely get people out of the area and repair the damage. So you should always assume if you see a power line on the ground, it's still on. So stay away from it. If you see something like that, turn around and run away as quickly as you can. So one of those scenarios, though, has to do with car accidents. Believe it or not, once in a while, a car or a truck or something will hit a power pole or a transformer box and power lines fall down. Ooh, that could be a very serious situation. So here's a question for you. Are the people inside the vehicle, are they being shocked by the electricity? Believe it or not, they are not. The car is being electrocuted and it's now going into the ground because remember, that's where it wants to go. It wants to find the easiest path to the ground. Now, some people say, well, the rubber tires are protecting the people, right? Not really. Here's what's really helping them. Look at the people inside the car. Are they touching the ground? They are not. And so they're actually safer inside the vehicle than trying to get out of the vehicle and running away. So if you ever get yourself in a situation like this, stay inside the vehicle until help arrives. So unfortunately, the person that might get hurt is the person on the outside, the rescuer, the person who tries to come up and sees the accident and tries to help the people out. Let's set this gentleman up here as the rescuer. I'm going to put my equipment back on and show you what could happen to this gentleman if he gets a little too close to the vehicle, because remember, the electricity is now going out into the ground. Let's take a look. So as he walks up to the vehicle and says, hey, let me get you out of there, or let's say he tries to move the power line itself. Oh my goodness, a lot of problems can occur just by the man walking around in this area. As you saw, the man did get electrocuted, unfortunately, just by trying to be a rescuer, which is wonderful, but the best thing to do in this scenario is stay away and call for help. Call 911. They'll send the first responders out. They'll call Idaho Power out, and we'll help those people get out safely. All right, we'll move on to another scenario here. Let's talk about those underground power lines. More and more, our neighborhoods, our schools, our businesses, our shopping malls now have underground power lines. We still see a lot of overhead things, but now we're starting to see these sorts of things in our neighborhoods. The big green boxes, have you ever seen those before? Probably. You may wonder, what are they? Especially when you're sitting on them or playing around them or jumping off of them. Should we ever do that? Probably not. The best thing to do is stay away from those, because inside that big green box is something called a transformer, something very similar to that right there. That too is a transformer. But inside that box right there is a very powerful machine that sends electricity to your home and to your neighbor's home as well. And so this is why we take those big boxes, we lock them down, we put stickers that say danger, high voltage. And so here is the possible danger of opening up a box and getting a little too close. Again, I'll put my safety glasses on and my rubber gloves. And here, unfortunately, is a possible accident waiting to happen. And so, as we've demonstrated again, stay away from those green boxes. Don't climb on them, don't jump off of them, and tell your friends the same. Remember that what's inside there is a very, very dangerous machine. Speaking of underground power lines, here's a scenario that a lot of people forget about as well, especially when people begin to dig in the ground. We always encourage people, if they need to dig a hole for planting a tree in the front yard, or if there's a construction site, we encourage people, call an organization called Digline. It's a very simple number, 811. Those folks will be nice enough to come out for free and locate all of your underground lines before you start to dig so you can dig safely. But let's show you a scenario where maybe they didn't call ahead of time. So let's say this is a construction site. I'm going to connect my underground power line, which happens to be right here. So our backhoe operator, unfortunately, didn't locate the lines before he started digging, and here is the result of that. Again, let me get my safety equipment on. Okay, and so our backhoe operator starts to dig into the ground, and here is the result. Oh my goodness. He just dug up a major power line. So as you can see, even underground power lines are dangerous as well. So again, as we reminded you, please call ahead of time. Call Digline, call that 811 number, and make sure everything is located before you start to dig. Here's one other concern though. The person inside the backhoe isn't the person that gets hurt, not the person that gets electrocuted. It may be the innocent bystander. It may be the construction worker that's working beside the person in the backhoe. In other words, as he's digging in the ground, perhaps his coworker or his boss is walking over to tell him it's time for lunch, it's time to go home. Unfortunately, he gets a little too close to the backhoe as it's being electrocuted, and he becomes that path to the ground. Let's show you that. As our friend approaches the vehicle, it gets a little too close, and he becomes the path to the ground. Another thing to be concerned about is the person may not even be involved in this sort of accident. Maybe he's just walking over here to the dirt pile to get the shovel that he left behind, but he's still walking into that field of electricity. Watch what happens. He's just picking up a shovel, but the electricity going through the ground makes him a path to the ground as well. All right, well, we've shown you a lot of different scenarios here. Hopefully you've learned a little bit of electrical safety, what to avoid, what to watch out for. Why does electricity look for the ground? Why does it travel at the speed of light? But I have one more question for you. And it's the question I get asked more than any other in my entire life, and that is this. How can birds and squirrels sit on power lines and not get electrocuted? That is such an interesting question. The answer comes in various forms. Lots of people think birds have hollow bones, and that's what protects them. Well, birds do have hollow bones, but they're still conductors. They're a living thing, so they have water in their bodies. Some people say, oh, they have a special coating on the bottom of their feet to protect them, kind of like those insulators. That has nothing to do with it either. Again, they're a bird or a squirrel. They're a living thing. So why aren't they being shocked? Let's go back a couple of steps. Do you remember when I said electricity is always looking for the easiest path to the ground? Well, look at our little squirrel or our little bird sitting on the power lines. Are they giving the electricity a path to the ground? No, there's no path. There's just air underneath them. So even though they're a conductor, and that's the confusing part, they're not giving the electricity a path to the ground. And so they're actually safe up there running around unless they touch each other or touch the power pole and the power line or a transformer. But as long as they're just sitting up there, they should be safe. Well, thank you all very much for joining me today. It's been wonderful sharing this information with you. I hope you learned a little something about electrical safety, but happy Halloween and have a wonderful day. Thank you.